I am Mr. Ish and I'm welcoming you this morning. We are looking here at the integral procedure for inverse sine and inverse tangent trigonometric functions. Interesting procedures involving integrating by parts and u substitution. We'll look at this one first. You want to do this, integrating by parts. Starting here with the inverse sine. U is equal to exactly what you see, the arcsin function, and then du is its derivative. You know what that is. It's 1 over root 1 minus x squared. V is the integral of what remains, which will be just dx, and you know that's going to be equal to nx. We bring everything here into this template, uv minus integral v du. U is your inverse sine function. V is an x, I'm bringing that here, minus integral vx du is this, 1 over root 1 minus x squared dx. If you want to be a little clear, you can put a dx over here. Here you have to do a substitution, polynomial substitution. I'll just bring the a because I already have u's being used here. A is equal to 1 minus x squared, dA is equal to minus 2x dx. dx is equal to dA divided by minus 2x. Bring that in here. This part here remains as is, x inverse sine x minus x over root a. dx is going to be dA over minus 2x. This minus will convert that into a positive. The x will cancel out. We'll bring a 1 over 2 out. X inverse sine x plus 1 over 2 integral a to the minus 1 over 2 dA. I'm bringing this up. When you do the final integration, you know it's easy. X sine minus 1x plus, this is going to be n plus 1 over n plus 1. You can have a minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1, which is a 1 over 2. That denominator 1 over 2 will flip around and cancel with this. You'll just basically end up having this 1 minus x squared and then plus c, and this right here will be your antiderivative of the inverse trigonometric function, which is right here, arc sine x. The inverse tangent function's integral is even easier. You are looking at this one now, so it's going to be exactly what this is. Arctan x, du is the derivative of this, which you know is 1 over 1 plus x squared dx. V is exactly the same. Integral dx, which is just an x. Bring everything right here. You'll have a uv or vu, either way. X tan minus 1x, which is your arctan, minus v, you know, is an x du dx over 1 plus x squared. That's what you have. Do a u substitution. Here we'll call it an a substitution. A is equal to 1 plus x squared. dA is equal to 2x dx. And dx is equal to dA divided by 2x. Bring it here. X tan minus 1x, which is your arctan x, minus this 1 over 2 can come out. The x and this x will cancel out. You'll have here a dA over a, because a is equal to 1 plus x squared. Bring it up as a natural log. You will have x inverse tan x minus 1 over 2 natural log a, but a is 1 plus x squared plus c. That right there is our antiderivative, and it should be good. So there's not much involved with both of these, but these two are the most common, and then the next most common would be the inverse cosine function. But that's what I'm showing you here in this video. Have a good day.